I hope you're not too tired after yesterday's party, and we'll try not to be very boring, or if you want, we'll let you sleep a little bit, but we'll see. And so the state of code coverage for Kotlin, and let us first of all introduce ourselves. I'm really happy to introduce my colleague Evgeny, who is principal software engineer at Sonar, and also he is JCoCo project co-lead. So today he'll be responsible for the code coverage part of our talk.
And I'm also super happy to introduce to you my colleague Marharyta, staff software engineer also at Sonar. She is also Kotlin Google developer expert. You could find her on various networks such as X, or former Twitter. And as a Kotlin Google developer expert, she's going to be responsible for Kotlin in our talk today. Before we start, we need to do a little disclaimer. As you might have guessed, we work in the same company, Sonar. You might probably use our products. Let's do a quick check. Who uses Sonar Lint, Sonar Cube, Sonar Cloud? Don't be shy. You might use them, you might hate them. That's fine.
Should I raise a hand?
Yeah, please raise your hand. It's fine. We don't really care today if you hate those products or not, because whatever we're going to tell you today is our own opinion, and it has nothing to do with our employer. And I think there is one more important thing we should mention before we start.
So I'm Ukrainian, and I was born, raised in Kyiv, and almost the whole my life I lived there. And today, you know, my country has huge problems with our neighbors. We're struggling, and we need all the help that people can give us. So if you haven't spent all your money on the ticket to droidcon, so you can, and if you feel like you want to make a donation, this is a trusted charity fund that you can use. So feel free to scan the QR code. The most important and serious part of the talk is done. Now let's have some fun.
So apparently I'm going to be responsible also for fun part, right?
Yes, it means we are all doomed here.
Okay, let's try. So we're going to talk about code coverage today. What is code coverage, Margaret?
Yeah, what Wikipedia says about code coverage you can read on the slides. According to me, to my personal feelings, is the measurement, is a metric that tells you which part of your code was executed when you run your tests. And in my life, in my career, in my actually project that I maintain, we like code coverage very much. We use it in our daily life. And there is an interesting story that happened to us. This is a Sonar Kotlin, the project that we might maintain, and static code analyzer for Kotlin. And previously, it was written in Java. And when we wrote it in Java, we had some targets for code coverage for the new code. And let's maybe have a quick check with you. What should be the target for your code coverage in the new code? Like, who thinks it should be 60%? Maybe 70, 75, 80, 90, 95, 100, 110. So we agreed in our team that we'll maintain 95%. And it was pretty easy, pretty okay to maintain this level of code coverage. And then we decided that we should rewrite this tool in Kotlin. We did it, and we could not maintain 95%. We barely managed to reach 85, and now we are slowly improving it, but I think it's still around 90 and not 95. And today, you're going to learn why things like this happen and what is behind this huge change. So, Evgeny, maybe you can elaborate why things like this happen.
Okay. Before, let's recall a little bit of history of code coverage for Java and for Kotlin. In 2003, there was a great project, Emma. If you are with Android since the beginning, you might even remember that this tool was actually used in Android SDK prior to JCoCo. There was another great tool, Cobertura, but it never worked for Kotlin. Both those tools are not maintained a lot nowadays, but they're in our memories. In 2007, there was another great tool, Clover. Unfortunately, it's source-based, so it was never adopted for Kotlin. It's Java only. In 2008, we got Android 1.0, including EMMA for code coverage. In 2009, there is a rise of new wonderful coverage tools. And it's interesting that the three tools about which we are going to talk later today, they appeared approximately at the same time in history. So it's Jacoco, JetBrains Coverage Engine, and so-called p-test. In 2013, we add to the Jacoco so-called offline mode for better support of Android. It becomes a tool of a choice for Android developers. In 2016, only at this moment, we get a Kotlin. And well, we need to do some fixes in Jacoco for Kotlin. We need to do some fixes for JetBrains Coverage Engine for Kotlin, and so on. So in 2018, we finally do the first commits in Jacoco to better support Kotlin. We do this actually with a great help from, let's say, our colleagues, friends from JetBrains. Thanks them for this. In 2021, we get so-called cover Gradle plugin. Don't be fooled here. Many people believe that Cover is a new coverage engine, shiny, brand new one, developed specifically for Kotlin. No, that's not the case. Cover Gradle plugin, still under the hood, uses good, old, well-known code coverage engines such as Jacoco and JetBrains Coverage Engine. It's just a Gradle plugin that simplifies integration of those tools in your Gradle builds. And here we are in 2024. So what is the state of those code coverage tools for Kotlin today?
Let's maybe focus on a few tools, not all of them, because of course they're nice, but we only have 40 minutes to talk.
As I said, well, I cannot skip the tools that I developed. So today we're going to look at Jacoco. Here is the report that you probably know if you can generate a code coverage report with Jacoco. It includes pretty interesting charts, missed instructions, missed branches, etc. We could see line highlighting, branch highlighting. So here is our shiny hello world with 2 branches. All of them are covered. We wrote some tests, etc. And apparently, as far as I can see, Margot chose that Pikachu is going to represent Jacoco in our talk, right?
Yeah.
Okay, what is the next tool we should take?
Yeah, I think it would not be fair to talk about Jacoco and not talk about JetBrains Coverage Engine. So the next tool is JetBrains Coverage Engine. So here it is, and we can see the Bulbasaur who will be fighting for JetBrains Coverage Engine today. And the report looks pretty similar. So you also have percentages like classes, methods, branch, line, instruction coverage, and also everything is painted in green or red if it's not covered.
Yeah, pretty similar.
So looks pretty similar, maybe a little bit different design.
Is it enough?
No, I think that's not enough because it's not fun to fight just 2. Let's fight 3.
Okay, the third one. We already mentioned it. It's p-test. It's not actually a just code coverage. P-test is a little bit more than code coverage. P-test is so-called mutation testing tool. Indeed, it computes code coverage just to understand association between your tests and the main code. After it's done, p-test tries to modify your main code, introduce so-called mutations in it, and after the mutation, it executes associated tests. If the test passes, then, well, mutant was killed, it's good, and if test failed, then mutant was killed, that's good, and if after mutation test passes, then, well, mutant was not killed, it's not good. And here is our hello world example. We could see that there is a couple of mutations, like we remove it conditional, replace it equality check with true, and unfortunately this mutant survived. This is not good. That's why the line is red. And actually this reveals that our tests are not great. On the line 13, we call indeed a method with parameter false, but we never check the result. That's why test passes. That's not good, and that's what p-test tells. It's a little bit more than just code coverage.
Yeah.
3 is enough?
Yeah, I think 3 is enough. So let's do some comparison. But honestly, I never did comparison of tools like this, and they're so same and so different. So maybe Evgeny is the main co-lead of JCoco. Can you elaborate and help us to test them?
Well, usually when we work on JCoco, we do test various language features. So let's test some language features and see how those tools behave with those language features.
Let's do. And what would be the first language feature that you recommend?
Well, I like one from actually Java, try with resources. This is the feature from which we started improving code coverage reports for users in JCoco and for Kotlin as well later on. Let's try with resources. Here is my shiny Java code. I have some resource, file input stream. I open it, I read something from it, pretty simple, pretty stupid. I can test it, I can write some assertion. If I read from def random, I expect that the result is not 0. Here is my test. And, well, I expect 100% code coverage in such case.
Yeah.
So let's check. Here is JCoco, all lines are green, everything good, 100% code coverage. Let's check JetBrains coverage engine, everything is green, everything is fine.
Stop, what are you saying?
Everything is green here.
Can you look at the line 10?
Line 10, it's green.
Okay, always forget that you're colorblind.
What?
So indeed, for Evgeny, line 10, it's green. But look at the branch percentage.
Okay. It's not 100%.
So on the branch percentages, you can see that it's only 25%. So something is not covered here. And for some reason, JetBrains coverage engine shows different result.
This could be one of the comparison points, like colorblind's friendly. Who else here is colorblind? Nobody. I'm the only.
No, there are a few people.
Fun fact, JCoco report is not better than that for me. I always struggle with JCoco report as well. Let's move on.
Let's move on, check p-test.
Now I think it's all green, right?
Yeah, here it's all green, so we can see that JCoco and p-test show that everything is covered, and GB says that it's not. Do you know why?
Why JetBrains coverage engine shows that it's not all good? To answer this question, we need to look into the bytecode a little bit. So we're going to use today my favorite, another favorite tool, so-called Java decompiler, Java P. It is part of OpenJDK. It's part of standard OpenJDK distribution with two parameters. We're going to use it, -v verbose, -p, show me privates, protected, everything. Those two parameters, -v, -p, I usually call them show me everything. So we compile our example and do Java P -v -p, our example, and we see, oops, yeah, and we see the bytecode. Once we see the bytecode, I think it's pretty obvious why we don't see 100% coverage.
So come on, you can read here, but you can distinguish yellow and green, yes?
Yes.
Can you zoom a little bit?
Sorry. Okay, I should zoom. Now it's obvious, right?
Okay, maybe you can highlight some important things.
I think I should elaborate a little bit more. The fun fact is compiler introduces a little bit more of code under the hood into your class files than you see in the source files. And in case of try with resources, there is many execution paths that needs to be covered. When the resource was null, what should we do? If the resource was not null, once we're done dealing with the resource, we need to close the streams. If there was an exception, we also need to close the streams, etc., etc. So for all those reasons, under the hood, there is a little bit more than we see in the source code. There is some null checks, and so on, so on. All of this is not in the source code. All of this is seen by code coverage tools as JetBrains and as JCoco because they do analyze the bytecode, not the source code. And after that, they need to map the bytecode back to the source code. This is a little bit of a challenge. Some things needs to be merged together, some things needs to be ignored as a code which is generated by a compiler. That's why we implement so-called filters in JCoco, and JetBrains coverage engine does the same. And most likely for the try with resources, they forgot a little bit of the work here. That's fine.
Okay, but we hope they'll fix it. But there is something strange here. I know you're Java champion, you have to promote Java, but the title of our talk is the state of code coverage for Kotlin. Really? Why do we even talk about try with resources during our talk? Let's find something that is more Kotlin related.
Okay, what about when on the string? Is it a Kotlin feature?
Do you agree it's Kotlin feature?
Why? When on the string exists in Kotlin,
Okay.
right?
Let's test. Let's test.
Let's try. So I have when on the string with 4 branches, with 4 values, A, B, C, and the default. Can you write a test for this?
Yes, I think I can, if you press the button on the clicker.
On your magic keyboard, right?
Yes. So we can see that there are 4 tests to test all the cases. I expect it should be 100%.
Let's check.
Let's check.
All green with Jacko, all fine. Now it's all green. I look on the numbers. Numbers are fine, 100%, but wait a second. Now that I look on the numbers, I think we all agreed that there was 4 branches, right? Like A, B, C, and the default. Well, again, maybe they filtered a little bit more than needed in this case.
Who cares? It's still green.
It's still green. That's fine. Okay, let's move on.
And
P-test.
P-test.
What happens with the P-test?
It says that some mutations survived.
Remove it conditional. Replace it equality check with false. Replace the equality check with false. Survived.
Probably it says that there are some equality checks.
There is a switch. Come on.
That we didn't write. So let's look into the bytecode.
You're right. Let's look into the bytecode. Oops, again, something happens. This time I also need to zoom in a little bit closer. Now that we look on the bytecode, I hope it's more obvious to you. No explanations needed? No, okay, let me provide some explanations. Indeed, a switch is a switch in the bytecode. But unfortunately, in the bytecode, there is no switch by string. How we can implement the switch by string? Turns out that it's pretty efficient to implement switch by string in the bytecode by first switching by a hash code. For most of the cases, it's gonna work fine. Like on the very first switch, we already is gonna determine which branch we need to choose. But there is a trick. Different strings might have the same hash code. So to be certain, to be sure, we also, after the switch by hash code, we need to do the string comparison, an equality check. And that's exactly what p-test, which also works on the bytecode, complains about this equality check. P-test tries to modify this equality check, but our test never verified 2 different strings with the same hash code, and our test passes after such modification. That's the explanation, but don't worry. Is it the end of the world for p-test? No. They actually wanted to improve situation for Kotlin. It's not easy to work with the bytecode, so they improved it with a commercial extension for the p-test.
So with enough money, we can have support of Kotlin and transform our chairman there into Charizard.
And this extension for p-test, commercial one, is called arcmutate. If you run exactly the same code with arcmutate, we see everything is fine, 100% coverage. As promised, it works for Kotlin.
Oh, I see. Deal. But you know, anyway, when existed in Java, like with switch, it's not a new feature.
That's why Pavel complained, right?
Probably, yes. Let's talk about something that is true Kotlinish, and I probably know that Jacob has something to tell us about inline functions.
Okay, show me. Show me the code.
And today, like since now, I'm going to be responsible for the examples because you know you always pick up Java ones. So inlines, I wrote some code. Here it is. There is a stupid simple inline function and 1 test for it. So let's check what Jcoco shows us.
Oops.
Jcoco broken a little bit and Pikachu is set. And we're gonna explain what happened a little bit later, but now let's check JetBrains coverage engine. So this one is all green. And
do you want to test arcmutate?
I would love to test arcmutate, but unfortunately I was not able to generate a report from arcmutate, and here I need your help, maybe to help me to generate it.
Maybe you're a Kotlin expert, but sorry, your example is overly simplistic, I think. Can we complexify it a little bit? Like, can we make, for example, a return type of your lambda nullable?
Yeah, okay, I think this one I can do. So I change the return type, and then we need to add a save call operator and the second test with null. Okay, let's check. We are not going to check JCocoa because it
doesn't work,
doesn't
right?
work, but the interesting part that JetBrains coverage engine now doesn't work too. It says that we
This
forgot
line
to
is
cover
partially
something.
covered. There is no branch coverage anymore. But we tested all branches, right?
Yeah, but we tested everything.
Okay. Does it help for ArcMutate?
Let's check. No, still no report from ArcMutate.
Okay, inline functions. Names suggest us something like inline. They probably inline somewhere. Do you know where do they inline?
No, maybe you can explain to the call site.
Yes,
Yeah.
Every inline function inlines into the call site. Can we do one more modification? Can we move a call site outside of the test? Because what I said earlier about ptest and arcmutate, it modifies your main code, not the test. And all the call sites for those inline functions are within the test.
So you're saying to me that ArcMutate doesn't generate anything because it doesn't see anything, because just all code is inlined in tests.
All code is in the tests.
Okay,
Yes.
let's add one more modification and extract them into separate call sites. And JetBrains coverage engine doesn't work, but yeah.
Does it help for
But it helps to ArcMutate, and ArcMutate indeed works and shows that everything is covered. And now, probably you can explain a little bit more what happens with
why JetBrains doesn't work? You all probably can guess. We need to look into the bytecode again. So here is our bytecode. Don't know why the scroll doesn't work. Here is our original inline function. As you can see, here is a null check. It exists here in the original. Now let's look at the first call site where it was inlined. As you could see, there is no null check at all. What happens is, yes, indeed, Kotlin compiler inlines body of inline function into the call sites. But if it would be the only thing Kotlin compiler does, it's still more efficient than just doing a call because we avoid a function call. But we can do better. If we know that some condition never evaluate into false or into the true, we can avoid evaluating those conditions. So we can do the optimization here. And that's exactly what Kotlin compiler does. In the call site 1, there is no null check. Let's look at the call site 2. There is no null check as well. Now, what is executed during the tests? Only call sites, never original one. So JetBrains coverage engine does see the call sites, but never see the original branch here. And that's why it says, well, original had the branches, but the call sites do not have branches. And it's not so easy to map the call sites back to the original because, well, we lost some information. We did some more optimizations here. And that's why JCocoa didn't work it. But you know what? We've been doing the same talk about a month ago at Kotlin Conf. And just before the talk, I got some free time to work on JCocoa and got some ideas how to improve the report. So here is work in progress, proof of concept. We will get soon, hopefully, code coverage for inline functions in JCocoa.
So it's coming. I think we should stop talking at the conferences and start actually implementing stuff.
You mean I should just go and work? Go. Okay. Let's move on.
Yeah, okay. And today is 2024, and it's impossible to imagine the Kotlin without coroutines. And I think I just had the talk from Martin about coroutines at the same stage. And do you remember actually when coroutines appeared? In which version? If I'm not mistaken, it's 1.1, but in 1.3 they were finalized. Yeah, okay, we can check. But anyway, it's pretty old feature. And let's check how tools support it. So this is a stupid simple example with calculating Fibonacci numbers with sequence. And we're using yield, so suspension points. And let's write some tests. So I think that should be enough because there are not basically no conditions. And I expect 100 coverage. So let's check. Okay, JCocoa shows everything is green.
JetBrains
also shows that everything is green. Okay, two different coverage engines show that everything is green.
Should we check ArcMutate?
Yes, but it supports Kotlin. That should be everything okay.
It's promised that we paid money.
We paid them to support Kotlin.
Well, shit happens, that's fine. We're not gonna go this time into the bytecode. I think you understand what's happening in here. Behind coroutines, there is a little bit more than we see in the source code. There is probably some bytecode generated on top of our source code. And well, argmutate didn't work well with coroutines. That's fine. Maybe this will be fixed at some moment in time.
Just even money sometimes cannot help.
And well, you know what? Yes, you're a Kotlin expert. Yes, title of our talk is code coverage for Kotlin. But let's don't forget that we are at droidcon, conference for
But it's Droid, it's not Android.
developers. Android, right? Maybe we can talk about some Android feature.
Yes, and I think I have an example. It's compose, but honestly, I'm not an Android developer, so this is how I write compose.
Probably not the best way to write composable functions. Probably what we just wrote here doesn't make any sense, right? You tell us. But that's fine as an example, okay?
Yeah, and
can write some
there are tests. Let's check the tools.
Let's check the tools. Oops.
So we broke JCocoa.
Well, doesn't work. Should we check others?
Yes. Oh, we broke JetBrains coverage engine bridge, and
The report.
broke them exactly the same.
Yeah, it's exactly the same. You see? The report looks really weird. Like, right, the very first line of a function was not executed at all, but the body was. It makes no sense, right?
Okay, and let's.
We test start mutate.
Yes, and I think it's
Pretty
also
much the same.
Yeah.
But again, don't worry, good news for you. We already fixed this. If you would like to test the snapshot of JCocoa, it works now for composable functions. This was done after
I think Android makers in Paris.
Android makers.
So every time we are at the conference, we are fixing something. Maybe we'll fix something this time too. So, and you probably heard that 1 month ago, K2 was ready. And fun fact, K2 was announced at KotlinConf 1 day before our talk. And we decided, okay, let's test it. We upgraded.
No. Don't change the story. We did not decide it. You asked me, hey, K2 is out. Can we update our dependencies and check K2?
Yes, okay.
What happened next?
And I think we tested everything except for one example, and we only noticed it during at the stage, so it was not nice. So we don't suggest upgrading anything before you have a talk. And so.
What about K2?
So I think we have some examples with K2.
Like you want a simple, stupid, what to test here? Which test you expect to write for the, like it's purely declarative. There is no logic in it. Do you expect it won't work or what?
Let's test.
Okay, let's test. So, well, doesn't work. Do we need to test JetBrains?
Let's do.
But what we should test here? Like, can you imagine? No?
I have no idea.
Okay. JetBrains doesn't work as well. Well, the tool from developers of a compiler of a language, well, okay. Again, maybe for you as a home task, you could come back home and look at the bytecode of Enum and compare what changed between K1 and K2.
Yeah.
Yes.
Yes. Okay. I think so far we've been focused on the correctness of the reports, but there is one elephant in the room that we forgot to think about.
What elephant? What's observer effect is?
I think observer effect from physics, it's actually the fact that you are observing something might actually change the behavior of observable. And we might think about it that the fact that we are measuring code coverage of some program might actually affect the behavior of that program.
Oh, now I remember. I have one example for you. So there is interesting statement in Java virtual machine specification. I'm not going to read it, but basically there should be cooperation between compiler and the virtual machine on certain constructions to do a proper synchronization. And between compiler and virtual machine, it's established. The compiler and the virtual machine developed by the same people. And then, well, instrumentation for code coverage kicks in. we do modify something which is a result of compilation, and we supply it back to the virtual machine. It worked well because we always been looking on the result of compilation, so we see the properties which are there, we try to preserve them, so nothing breaks. Everything was working till, well, another instrumentation thing kicks in before code coverage. You all might know R8 shrinker, which is used in Android to shrink the class files, right? This shrinker also modifies the bytecode. It slightly rearranges things. It also preserves this property, but unfortunately, developers of code coverage tools, they never seen the bytecode like that, because this bytecode cannot be produced by the compiler. So we are not ready for the patterns that R8 shrinker produces. And here is a surprise. If after shrinking we will try to apply code coverage measurement, hotspot JVM is gonna complain about modifications that we did in synchronized blocks. It's gonna say, well, sorry, I'm not gonna try to JIT compile this code. I will still execute it, I will still preserve the synchronization guarantees, but it's not gonna be as performant as it could be. Well, that's fine, thank you, hotspot JVM. What about Android runtime? Well, Android runtime is gonna completely reject execution of such application.
Is there something we can do about it?
Yes, this happens, and it's pretty hard task to fix. All of the tools that we are showing today to you, they have this problem. Hopefully, with enough time, we can find a solution to this. Until we find solution to this, there is a workarounds. Like, you can slightly rewrite this code. It will work. If you cannot rewrite this code, like if it's in third-party dependencies, our recommendation is, well, don't measure code coverage for third-party dependencies. Exclude them. Unfortunately, you cannot do this, as far as I know, for Android projects because here is a feature request for them. What we can do as a community, well, we can go and vote for this feature so that at least we can start testing our application, excluding the third-party code. Hopefully, they would also help us here.
Yeah, and you know, you also reminded me about another observation from Observer Effect. It's performance. The fact that we are measuring performance, measuring the code coverage might actually affect the performance. And I did some tests on Sonar Kotlin. I ran all of these tools. And fun fact, like raw test without coverage is 57 seconds on my machine. With JCocoa, it's 1 minute 20 seconds. With JetBrains Coverage Engine, 1 minute 23 seconds. And with speed test, it's 1 hour, 20 minutes, 7 seconds. So you can see that speed test probably produces much more performance overhead because of the way how it measures.
But hold on.
JCocoa and JetBrains are pretty much the same.
Don't drop on the floor the p-test. This is only initial setup. Yes, for the very first shot, it's gonna take you a lot of time because you need to modify the code, run the tests again, etc., etc. But there is plenty of optimizations in p-test. One of them is super simple. You don't need to run all the tests all the time because you're not modifying all the code. So you can incrementally re-execute the tests and the time is gonna be reduced. So don't drop this option from consideration. It's still valid. And sorry, but like how you measure this? You took a whole clock? That's not a proper way of benchmarking, you know.
Okay, you want a micro benchmark?
Yes, I want to write a micro benchmark. So I wrote a benchmark, your favorite Fibonacci. I'm going to execute it without instrumentation, with instrumentation, or by 2 different engines. And let's compare. So here is what we are going to get. Here is our original. It runs, it produces, it can do so many operations in a microsecond. It's a little bit slower than doing nothing. It's expected. We are computing Fibonacci number. Then here is JCocoa. It's also a little bit slower than the original. This is expected. And now here is JetBrains code coverage engine. It's twice as slower as original and twice as slower as JCocoa. So yes, maybe in your unit tests you don't see observable impact, but clearly there is much more impact induced by JetBrains coverage engines than by JCocoa. So be careful. For some workloads, maybe one is better than the other. Like, I wouldn't put JetBrains in production. Jacoco, well, maybe we can use it in production as well, not only in the tests.
If you are crazy enough.
Oh.
So, okay, let's probably finalize our comparison.
So,
here.
Yes, we have a table. It's a little bit bigger than what we presented to you today. It's still incomplete. Like, maybe we can come up with better examples. This table already shows some work in progress because, well, between conferences we had the time to work. What else?
I think actually it's not
be careful.
Completely fair table.
Yeah, be careful. We are unfair here a little bit with you. There was recently a release of JetBrains Coverage Engine like last week. And I really wanted to retest it on exactly the same examples on the same table, etc. And this release probably was driven by some discussions after Kotlin Conf because, well, we presented this also for JetBrains developers. And they probably took into account this feedback and they did improvements. So this is not a state of today. Let's say it's a state of 1 week ago. I wanted to test, and you know, Margot didn't let me to do this time because she remembers that in Kotlin Conf it completely broke our talk.
Yes. So
let's wrap up.
Yeah, I think it's time to wrap up. So summary is like this: tools are not ideal. And you know that tools have false positives, false negatives, and sometimes they are not showing the right coverage, but they're still helpful. You still can use them. And if you use more than one tool, you can actually compare, find some misses in one or another tool. And don't hesitate to provide the feedback to each other, as JetBrains provides to us, we provide to JetBrains, and you users provide to all of us. And let's be nice to each other. All these tools here are not competing against each other. All these tools are here to compete, to fight against your bad, untested, and maintained code. So we are all here to achieve one nice goal of having your code making better and making the software better.
And so that's funny that you mentioned this. Let's be nice to each other. I think the goal of this talk was already achieved. Once we presented this talk at Kotlin Conf, sometime later, JetBrains again come back to the Jacoco and said, oh, hey guys, we see that you are struggling with inline functions. We do not. In our tool, we did some support for inline functions. Do you need help? Sure, thank you. I think it's great that we can help each other.
So, thank you for coming. I hope you learned something today. And that's it.